All right, so what are we working on today? We are going to do it down a little bit. We're going to work on some Linux. People that want to hang out and do some Linux with us can do that. People just want to hang out and not do any Linux can hang out as well. Hey, Enzo Bear, how's it going? Yep, do all the Linux. That's what we're doing today. I'm kind of going back to the basics. We're just going to start hitting the labs, right? I even called today beginner to enterprise Linux. We're just going to talk through Linux and walk through some of the things that I think you need to know. Obviously, we've got the course and other things that people can work on and work through to better understand this stuff. But today we're just going to get down into the technical stuff. So, yeah, anybody that wants to kind of follow along can do that. I'm going to start right here in our first lab, which is system checking. And I will link this to any of you guys that want to do it. There you go. And we are going to walk through just, again, pretty much basics, doing Linux. You're a new sysadmin at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. I kind of think, man, if that's all I said, that would be a big part of what it is being a systems admin. You're just going to have a boss pat you on the shoulder and go, well, it's all yours. It's all your stuff now. Boris said you're over on the YouTube side. Nice. Yeah. You're welcome to hang out. And yeah, I appreciate you hanging out. And we're just going to be doing Linux on the left side. And then if we need to show anything on the right, well, that's a little more correct for what I want the windows to look like. So, but yeah, we're starting a Linux Systems Administration course up again. It's the same one that some of you guys did late last year. And then we're also doing a Systems Engineering course that is going to focus on securing Linux. It's going to be security in Linux. And I think that one will be good. Yeah, we check on Ranger real quick. How is Ranger doing? Well, he's down there on his bed. He does not like that pillow on his bed, that's for sure. But yeah, Ranger's moving around. He's having a good day. It's supposed to rain here in Phoenix tonight, so it's 68 today, which is a beautiful day, and then it's going. Yeah, Enzo, how you like it? I kind of think, because I got asked on the security engineering course if I was going to record it, and I think I might. But if I do record it, I might do a little more. I might have a little more respect for it. In that Ranger just disappeared. I might do my recording of it offline. So I may do it like record it in a vacuum, basically. Just kind of dump my thoughts, not listen, not you won't have any me talking to anybody or me yelling at anybody, which is kind of my normal. So, all right. Yeah, Ranger does kind of alternate between the beds when we check on Ranger over here. So, all right, let's get back into Linux here for a little bit and say, so you're new, you're sitting here and you find yourself at a command prompt and you need to find out what type of system you're working on. Other times that you might find the same scenario happening right here would be maybe you get a call out in the middle of the night and then you have no good documentation, or some other engineer was building these out for something, but you really don't have a lot of the specifics. Like, I mean, a lot of times in the enterprise, sorry, I'm blowing off my keyboard there. A lot of times like, hey, we run RHEL 7 and RHEL 8, and then maybe we're going into RHEL 9. So you've got these 3 different generations of servers. So you just need to figure out stuff about a server that you're going to. Yeah, and Zobair, I think it would be more professional if I record it and do it kind of in a vacuum. But plus it would probably be a little shorter because I won't be talking to the side and all that kind of stuff too. So we'll think about that. But yeah, for people that showed up a little later here, we're doing a course in our Discord. Those courses are always free. We don't charge anything for them. I think that the best thing that I can hear about those courses is people telling me that they're learning a lot and they're picking up a lot of this stuff. I think that's good. Before, that doesn't really mean that you're on an Ubuntu system. You can change this variable any way you want. You could call this sneakernet. Like, this has no real bearing on the type of system you're on. Also, this right here typically means you're a normal user, but I do a little who am I, and I'm the root user, right? And even being the root user, unless I see ID as 0, technically somebody could change around. So there's a lot of stuff that could be weird in the system. I'm not advocating doing any of that stuff. I'm just telling you guys, we need to see the way the system sees itself, right? So my favorite one is cat etc splat release, and that will show you the type of system you're on. We know that we're on Ubuntu, we're on 2004, and we're on 2004.5 long-term support. And you may look at this and go, what's that splat actually doing? And then we could investigate that a little bit. We could say ls etc splat release, and this would tell us that there's two different files that come with this wildcard at the bash level, right? The bash command we're doing is putting a wildcard there, meaning glob everything that shows up in that. So lsb release and os dash release, right? Both of those are there. But I could do a -L on that and see that actually one of these is actually a file right here. This one is a normal file. We can see by that dash right there. And the other one is actually just a link, a soft link, as it were. We see that L right there, to one directory up, usr lib os release. So the two files we're seeing are cat etc lsb release. That's one file we're seeing, and the other one we're seeing is usr lib os dash release. And you might say, Scott, you forgot those two dashes. Well, all those dashes are relative to the path that we're in. So we're lsing etc /release. So the path that we're looking in is etc. And this just says that the link is to the parent, which just means the root of the file system. This right here actually doesn't need the ... on it. The ... is just the relative path that, it's kind of funny, looks just like the absolute path. In fact, the relative path and the absolute path are the same if you take away the parent. But anyways, that's neither here nor there. And then we can see that. So those are the two files we're actually looking at. If you ever wanted to like take apart that little command I'm always showing you guys, the cat etc splat release, it's just, I'm cheating. And the reason I show you guys this is this. In my 20-something years of doing this professionally, this will catch almost every, I mean, pretty much every distribution of Linux and Unix I've been on. This will give you at least enough to know what you're on with this one command. So this is like my little shorthand cheat to find what type of system I'm on. Does that make sense? YouTube had commercials, so you had to switch to your phone. Sorry, Boris. Camby, how's it going over on the YouTube side? We are just kind of hanging out, and I just figured I'd do a little bit of Linux, right? Talk a little bit of shop. I don't have any college classes tonight. I think the wife's going to be a little late tonight, so I'll just keep an eye on her text. And I do have some Stig work to do here in a little bit, and I'll do that on my own time here. But I figured we'd just work through some stuff, hang out a little bit. Just said, nice, I normally use uname. Yeah, uname works as well. That's actually the next part, which is the kernel stuff. This is the version of the operating system we're on. But then one of the next things we're going to do is what's the kernel version, which will be uname -r. Now, there's also uname-a, uname-a, which will give us all kinds of cool information. And uname-m will give us very specific information. Now, the reason we tend to use something like uname-r or uname-m is maybe for architecture stuff, right? Like maybe we're downloading something and we want to make sure that it's using the right version of a kernel that can support it or something like this. Can cat etc, hold on, let's try this one. Cat etc issue. Okay, that gives you some information. I didn't know that. And that can probably be populated depending on your organization, so that's a good one. So yeah, that gives us some information about it. Now, the uname-a is good if you want to check everything, but the reason most of us want to know uname-r is because that's, maybe like a kernel version, right? So then we should be able to, if we know the version of the kernel, then we can do checks inside of our scripts and say, as long as the kernel version is 5, 5 dot something, then go ahead and do this. Or as long as the architecture is x86-64 and not like ARM or AMD or something like that. AMD, sorry. AMD is still valid x86-64, but ARM 64 is a different architecture, which not all things will work with. Hey, Fisherman, how's it going? Hopefully you're feeling better. I saw that the bot was feeling better, so that's good. If you guys don't know, Fisherman runs the bot in our server that kind of welcomes everybody and says hi and talks trash and makes sure that you spell my name wrong and all the kind of good stuff that we need to keep the community running. So also, we're trying to get, by the way, thank you for that Quartz one, the resubscription. I appreciate it. Keeps you guys from having to look at the ads too much and stuff. But we're also putting together the Linux sysadmin courses coming through again. And then not just the Linux sysadmin course, but there's also a security course coming up. Is that just say, it thinks I'm just saying sys? Oh, yeah, okay, there it is, sysadmin. I'll just say systems administration. Apparently it's not getting my Lisp. All right, Fisherman said the bot needs a new brain. They're decommissioning the current model, so I'm using, got to swap it out before the end of the month. Okay, fair enough. Fisherman, are you going to run it on, I think last I checked you were running it up in AWS, right? Doing all that kind of stuff. But that's good. That's good. All right, Packle Wrap. I always wonder if there's a fixed failback package name scheme that is package manager agnostic, using commands like uname to build the needed name automatically. Yeah, I don't know. I don't know what all the package managers do under the hood. I've never really dug in much to the package managers. I will tell you, for the most part, if you do try to install things, a lot of the package managers are looking at the for sure the architecture of things. I was thinking more along the lines of some of the scripts that you can download out there in the world, where you go to install like a what's that Llama script? We'd have to get out of this lab. There's a lab that Fisherman wrote that shows how to run Llama, and when you download the script, there's kind of like some basic little bash logic to look at the different versions of things that are going on and stuff. I think that's kind of useful. Oh, Fisherman, you're still running it on your Pi? That's funny. I got a bunch of Rocky boxes now. I mean, I know you had tried to run it on the older Ubuntu stuff that we had. By the way, some of you guys, let's see, is my Excalidraw up? Yeah, there's we've got quite a bit of architecture going now. People have been adding to this, so this is why some of this is kind of messy. But we've got quite a bit of stuff that people can get access to in our environment now for people that want to get into and do Linux in a real professional Linux users group lab environment, All right. So anyways, let's go look at the actual answers here. We've got cat etsy splat release, uname-r, uptime. I think I've told you guys this. Uptime is probably one of my favorite commands in all the world. I get to a new server. I've never been on the server before, but somebody's insisting that there's a new issue of some type. One of the first things I'm going to do is see how long that box has been up. I want to see what's been going on with it, that kind of stuff. It all costs money. I never set up a followage command, unfortunately. To set those up, you got to get into Nightbot and do all this other stuff, and I never bothered to do it. So we'll just say you've been here a long time. Yeah, it's the user equivalent of uptime. Fair enough. That is actually true. Yeah, I know Rossberger, who I like to kind of hang out with in his stream. He's got a watch time and also follow age. So yeah. I don't have any of those cool ones, Enzo. In fact, if you guys do commands, you'll see all the cool commands. I was driving home from the gym this morning. I got done wrestling, and I was driving home, and I was like, nobody ever uses our objection anymore. I need to get, I was like, how do I build a culture around people using our objections? I need you guys to do objection, and it objects to, well, you can actually do objection and then name. So you can give an objection to other people when they say stuff, and then I can overrule or sustain those. I think it's hilarious because it comes from that old what's that called? That other stuff. And then dungeon. Yeah, we haven't run the dungeons in a while, but we do have sandboxes that you guys can get into still that are treated like the dungeon environment. So it still exists. But anyways, all right. So let's get back to this. We do uptime because we want to see what's going on with the system. This system's been up an hour and 37 minutes. So if somebody told me this was a production server and they called me out and said something's going on with the server, we have no other information, my first piece of information was, well, if this thing wasn't supposed to take downtime in the last hour and 37 minutes, we've got a problem. Something's happened to this server. Then over here, I see load average, and this load average is nil. There's nothing going on this server. This server is literally sitting here doing nothing. So then I would think immediately from these two pieces of data, like if you guys want to know what I would extrapolate out of this, if I knew what this server was supposed to be doing, like let's say this was a backend web server, right? And I'm like, all right, we got a web server. I would say, okay, he's come up and he's not been put back into rotation because he's not healthy in some other way, because there's no load on him. Nothing's being sent over here. Probably the load balancer doesn't recognize that he's back up. Probably have a service down of some type. So then I can come in here and start trying to figure out what's happened to the system. But uptime is a great way for me to start that. And you might say, Scott, what do you check on a server that's doing stuff like that? Well, I do system CTL. I'll do stuff like this. I'll do system CTL failed. And I will see, are there any services on this device that did not come up like I expect, right? Like, is there anything? So failed will show you all the things that have come up, but are not what we kind of expect. So let me pull this up real quick. I go over to like my home lab's always got good examples. Let's get out of there and say system CTL failed. Whoops, so it'll help if I spelled system right. System CTL. So now, if you guys want to know how healthy my box is here, this server I have, well, when it came up, it had 4 services that did not come up to fully working system. No, pack. So hold on, over here. 0, 0. This means no load. So what these numbers mean? This is the 1, the 5, and the 15-minute timer right here. That's what these numbers are. They're the 1, the 5, and the 15-minute. They're sliding window of wait time against the processor. So this number's actually, depending on the box you're on, this number means totally different things. And what I mean by that is this: if I come over to, let's just stop him real quick. What's going on here? Control C. Yeah. If I do an uptime on him, and then I see that he's got 4 CPUs, right? That is a slightly different. He's got no weight against 4 processors, right? That is slightly different than like over here where I say uptime and then I say nproc, and this is against only 1 processor. So you would say, well, what's a high load? Like what's a load average that you would consider high on a server, right? And what I would tell you is it's in relation to this, because once this hits 1 in any way, that means that you're starting to experience wait time against the number of processors. So you're waiting, your processes, your different things that are happening in your system are waiting to use that one processor. However, over here, if you even see like the number 3, but you have 4 processors, there are not necessarily processes waiting for that, because there's enough CPU time for that. Now, there are things that can interfere with that, meaning like, let's say somebody wrote something to not be able to use more than 1 core. Well, they might never get a high load average on that box, but they might make one core. So this might be running at 1, and one of your processes may be running like shit, even though you have extra cores over here sitting idle. But that's because of the way the process was written. And then you say, well, Scott, how do you check that? Well, you've got these other commands that are kind of useful for that. You've got one of my favorite ones for that is vmstat, because if we do like vmstat, and we'll just say 1 like 5, right? What happens over here is this box is hanging out chilling, and it's got 4 cores. But right here, you would see if any of your processes that were using memory were waiting. So the R here and the B for procs. This is in relation to if the process is actually, if there's like a thread waiting on a processor core. So if you do like man vmstat, you'll see what I mean by that. So it says right here, it'll tell you what those things are doing. You guys can see that on my screen. Yeah. So the number of runnable processes running or waiting for runtime, that would be your R's. And your B's are the number of processes blocked waiting for I/O to complete, which means like you're using a whole core, but you can't do anything else. That's the number of processes that are blocked or waiting for that. So when you say, well, Scott, how do you know like if a system is healthy? Well, obviously uptime's like just the cheapest, dirtiest thing. It's just showing you, okay, there's nothing going on. But then when you do a command like vmstat, it'll show you for individual processes And what you'll get is if we put this under load, you would start to see different processes blocking here and waiting, if that kind of makes sense. How does the average differ on multi-CPU? Yeah, so Pack, yeah, the average will be on multi-CPU on this. You may only see, like a 3 here or something, and that would mean that you're not actually experiencing wait against all your cores, meaning that a new process should be able to get in there and run, if that kind of makes sense. Now, you'll see sometimes you'll be on a box, like I work on servers sometimes that have big databases on them, and they will have, 64 cores or 124 cores in them, so they'll be pretty good sized boxes, but they'll be up here at like 13,000%. That is not healthy. That is not good. But that being said, sometimes the databases are still fine because while they're holding everything open, they don't have like blocking. So what I'm saying is this is a very high view. This would be like me looking out of an airplane at 10,000 feet and saying, oh, it looks like the land is pretty good. But if the land is burning, then I might come down in here and see how much of it's burning, right? Does that kind of make sense? Like our tools get more and more granular depending on where we want to be. And the guy that I always tell you guys to look at for that is this, what's his name? Brendan Gregg, this guy. I'll link this to you guys. But if you're like, hey, Scott, I really, really want to get deep into Linux performance stuff, that's interesting to me. That's what's going to kind of get me going down this path. Go look at this guy's stuff because he's really got the standard for talks and tools and this concept of eBPF that you really get into. And if you're like really looking for millisecond latency, see, a lot of the stuff I do as like a Linux engineer is the server's up, we're good. Like server's not really blocking. IOStat, IOStat -D for devices maybe. And I just make sure that the devices they're not red, things are good, nothing's really happening, we're good, right? Or that kind of stuff. Like, but then if you really want to dig in, these are these other tools here that exist and people that specialize in a lot of that stuff. Me, I dig down this deep when I have to, right? I tell you guys often like the idea of painting with a wide brush. Like I just a lot of times need to know like all my systems, my big fleet of servers are doing what they should. And if something's struggling, then I go dig in on what's going on there. So hopefully that makes sense. So one of the last ones that's really important on this lab is we do like a cat proc command line. So if you've never seen this before, proc command line is how did Grub, the Grand Unified Bootloader, call this kernel? What extra things were handed to the kernel at runtime to let it know, like, okay, the root file system that we need to switch root to off of our initial init ram fs is going to be this label here, cloud image root fs. And I go, how do I find that, right? I might cat etsy fs tab and see, oh yeah, there's that label, cloud img root fs. And then I might go looking for it down in dev disk. And then I might go buy, label in this case, right? So cloud disk by label, ls-l in here. And I see that this cloud img root fs, which is how we're mounting the system, there we go, boom, is actually VDA1. So then if I do like an lsblk, I would see dev VDA1 is that root partition of the system. So there's like all these things that you can kind of go and, man, there's so much stuff to like dig into in this. But I tell you guys, a lot of this stuff, and I think being good at this is really about understanding your system like at a high level and then digging down deep when you need. Yeah, Raleigh, I agree with that too. Before you go digging into things manually, you should have good monitoring in place. Yeah, because like even in my home lab, right, I can go look and see how my systems are behaving over, this is the last 7 days on all my servers that I care about. This is, some of the security stuff and how my DNS is working. Well, looks like my DNS shit's broken. All right, I got to get in there and figure that out. But my ping stuff's working, but this is all busted. I got to figure out what's going on there. And then, I have my logging type stuff, which I can detect anomalies and that kind of stuff. Here's all of our Hammer servers, so I can see if, looks like somebody logged into one of them, Hammer 16, and was updating things the other day. Was that even today? Yeah, somebody was in Hammer 16 working on stuff, because some of you guys know how to get in there. Yeah, Raleigh, absolutely. Yeah, knowing where to spend the time is absolutely critical as well. Mostly what I was focused on, at least when I started this, was just kind of getting into our first lab and going through some of the basics for people. So it says here, now let's dig a little deeper. Do each command and think about the output you're looking at. You may want to run them multiple times if needed to compare the output. So I clear the screen up here, and then I say vmstat15. So vmstat's that same command I was showing earlier. I can make this a little smaller so it's kind of nicer looking on the screen. But vmstat by itself doesn't really do anything. It just gives you one output. And then you can say with a 1 every 1 second until I hit Control C. Or I can say every 1 second for 10 iterations, and I can do that, right? So I can see what's going on in my system. And in this case, this system is also mostly chilling, not really doing anything. There's one runnable process and one slice of time that we saw. Nothing was blocked for access to the processors, right? That's what's happening here with the system without us digging down into like the individual processes, right? So, Twisted, you said you want to get better at monitoring. Do I have any useful resources? Yeah, I would tell you the best place to start for monitoring stuff is these books here, the SRE Google books. These are all free, and these have really good kind of discussions around how monitoring works. And then like Prometheus and Grafana, I do think I have some good resources for Prometheus and Grafana. If you go on our Discord, Twisted, I have a study guide for the PCA test. I still have not went and taken that test yet. I've been working on it for a while. I just haven't really dug in and went and taken it yet. But the PCA is the Prometheus Certified Associate. It's like their basic level cert test. I have some training on that and things to go look at on that. There's free resource out there. Like if I go cheat sheet for the Prom Labs, this is one of the best things on the web right here for you, Twisted. I'll link this to you real quick and then I'll show you. One of the reasons I like this so much is you can see about the selecting queries and stuff, and then you say, okay, well, but can you show me that live? And you hit this button and it takes you into a live Prometheus with that question there. And then you say, okay, well, but I saw that I can do 5 minutes and get aggregate times. Okay, cool. And then you could start to build your queries and really like understand this stuff, right? And really start to dig in on a lot of these different pieces. So there's all these little open, so you can go right into a Prometheus system and see what it looks like to count over time all the resident memory bytes for the last 5 minutes. And then it shows you how to do aggregation functions and tells you what these different things are doing. So that's where I would go, Twisted. So hopefully that's a good start for you. I do have labs that have you build out Prometheus and Grafana and that kind of stuff if you go into our killercoda labs as well. So, Enzo Bear, you deleted all your DPKG files. Yeah, that's probably going to be a rebuild. Yep, that's when you test how good your rebuild system is, right? So, all right. So, I come up here and then I say, what are you seeing here? Is this system under high memory usage or not? And no, it looks like we got a lot of free memory, a little bit of buffer, a little bit of cache. But we do have a lot of free memory, but I don't like this really for memory. I like doing some commands like free-m to see that, okay, we've got 2 gigs of memory in total, roughly, right? If we look at it in megabytes, and then we're using a very small amount, and we have a good amount free, and most of this stuff is over in buffer cache memory, right? And we can wipe the buffer cache and then see how much of that our system's actually using, right? I think I have a command for that here in a little bit. If not, we could just do it. But then we can check, like, what's the overall CPU usage of the system every 1 second for 5 seconds. So we run this one, and it tells us how our system's kind of running. And I know that's a little hard to read. Maybe I'll make that a little smaller. Normally I don't make things smaller, but I'll make it a little smaller for now for you guys to see that idle is the very high average, meaning this system's really just chilling, sitting here not doing anything. This system is just chilling. There's not a lot of user space, not a lot of system space as far as the time goes for any processors, right? Hey, thanks for the follow, Autistic Stick. Hopefully this stuff's useful to you. We are going through. Also, I got a cool little message today from YouTube. they said they're gonna automatically dub my stuff into other languages. So I'm like, that's cool. Hopefully, I've got like strong bad voice in some of the other languages. That would be kind of funny if it dubs me over. Um, it said it's gonna like dub over to Spanish and French and all these other things, which will make things easier for other people to watch. Which I think would be, I think that would be really cool, especially since my I generate my closed captions myself, meaning my closed captions would stay the same. And I do know that some people like to listen to something in their language and then read it in English. You know, it's a process some people use for learning English. So I think that's kind of cool. Oh, wife's texting me. Hold on. I gotta see if she wants me to call her. Give me 1 second here. I gotta go on mute real quick, but you guys will still see the. All right, I'm back. I'm back. Yeah, the wife's she's working right now. She works at a school district, but she was getting off a little early. Wait, hold on. So she wasn't getting off early. She's been going and helping the land techs, which are the people who go and like actually, it's LANTEC. Yeah, HS. Land techs, like that, not land. Anyways, whatever. This thing's not going to get it right, but it's local area network technicians. And they have been redoing all of the Wi-Fi for all the schools and all the high schools. So she's been going out and helping them in the afternoon, and people have been approved for overtime for it. But my wife doesn't need overtime. What she needs is more vacation time, because she has a hard time holding on to her vacation time, and we have like some kind of big travel coming up. So it's kind of funny. Like she's like, I have to work this overtime to get. She got it approved for them to just give her like vacation time, like almost just push the time into hours, if that makes sense, so that she can take time off in summer with me when we go down to like Mexico and stuff for my not to Lake Mexico. I don't think Mexico's whatever. Anyways, all right, let's keep going. Fisherman, you're on a Duolingo streak. Nice. Yeah, I need to work on my Spanish more. I have all the Pimsleur stuff for Spanish, Fisherman. I have the Pimsleur stuff for a lot of stuff, but yeah. Anyway, so MP stat, pretty good way to see things. You don't probably want to sit and look at this often, right? It doesn't make sense to just sit here and let this roll. But if you're like looking at a server and maybe you want to see, hey, maybe you got a set of web servers and you want to see how they handle new load on them, coming from like a new load balancer, or maybe they're expected to be taking in more traffic from something. You can monitor them like this, right? Have 3 windows up, maybe even in screen, and you're monitoring them just spinning like this. And then you take that load on the system and you can see how that affects the overall usage of the system in real time. Now, again, I tell people all the time, this right here is more for us when we're working on stuff as engineers, admins and engineers. We work on stuff like this. You're never going to give anybody, like outside of like a Linux admin or a Linux user, this kind of view, because there's something wrong with people, right? Like not everybody is one of us Linux engineers or Linux admins. Not everybody wants to be down here at the command line. We have to give them stuff like this. We have to give them, okay, this is the load on your system when that happened, and they can see the chart and go, I see, it was high when we did that test, and then it dropped back down. And you're like, very good. Yes, yes, you have learned. Very good, right? So the reason I bring that up is just to point out that like, you know, this works for us, and you can strategically think of how you want to look at this and how you want to see that load within a system. But maybe that's not something that somebody else wants to see. So let me show you guys this real quick. We could start this on here, and then I can come over here and start a new tab, and then I can just make sure. Let's see if I have stress. Yep, apt install -y stress. Let's put stress on this box real quick. And let's look at if we were to spin this system up to kind of like a high load, what would happen in this other window with this MP stat, right? Like our systems, you see it spinning up a little bit as it was installing, but now it's back to chilling. Okay, good. So I come back over here and I say, all right, stress. So we do nproc to see that we have one processor. So we say stress -c, maybe 4-t for timeout of 180. So for 3 minutes, we're going to stress this system at a high load. And let's actually see right here that, yeah, the system went to a really high load over here in user space, right? We see that in user space. Our idle is almost nothing anymore. And then we should be able to watch this and see if the system continues to behave. Maybe we want to spin up a system to maybe not 100% load like this, but maybe a little bit higher load than normal to see how the system behaves. If you know, maybe we were running a process and we say, hey, sometimes the system comes under load because of the backup turning on. Well, I want to make sure that maybe our system is still functioning on the front end. I don't know. There's all kinds of things that you can use. I'm just kind of describing and showing you guys the tools that you can use to develop your, in this case, this is kind of like a benchmark test. I'm spinning the system up to see how it behaves and see if my monitors are good. Make sure that I'm seeing things the way that I expect, you know, validate that maybe I might do this to validate that a trigger in Grafana sends an alert to me when a system's under high load. Because if I go do this on a server and it doesn't alert me through my Grafana monitoring, right? Like I come over here to Grafana and none of my stuff is spun up high. Well, that means that my alerts aren't set up right? Like I need to do this. Packlerap, you said, hopefully this doesn't count as blasphemy. Do I have a subset of tools that runs on Linux and FreeBSD, Illumos, NetBSD, cross-platform? No. So I don't have any of those kind of things. No. You'll find, Pack, you'll find that I am very vanilla. I am the most vanilla engineer I know, in fact. And I've worked with a lot of engineers over the years. And what I mean by that is you can like airdrop me into literally any platform. And as long as it's like a POSIX-based command line, I will start to figure things out with no tools with me. Like I'm like you drop me in with like a knife and a piece of rope. Like that's basically all I need. CD and LS and PWD, and I'll start figuring stuff out. But yeah, I don't like bring tools with me a lot of the times. But what I mean by that is I don't need the tools there, right? Like I don't have giant environment files and .bashrcs. The one thing that's like this will be funny for some of you guys. The one thing that's like non-negotiable for me is this. This one is I must have this file. This is the only one I need. Is my screen RC, and this one I stole years ago off the internet. No, this guy Christian Willis wrote it, so I always give him credit. But he said take it and use it, but it's my screen configuration file. This is the only one that like. And actually, speaking of, I can get around without it, but I won't be very happy. This is the only one I need because it does this to the bottom of the screen. Do you guys see the bottom of that screen there? Where when I move between my different environments, you can see you can see it across the bottom as it highlights. That's the only real thing that does. It does some other things too, but that's main thing like that. Yeah. But yeah, I mean, I do like bringing Ansible into every environment as well, and then I do have things that I'll pull down if I have Ansible. I need Ansible in general, but I can get around. So you guys know I can get around with pdish and bash. Like I can hit all my servers in. Like I've shown you guys this before, right? Like so, if I clear this up and I say cat etc, or if I do like wwctl node list -a. And I see all my nodes right? Or just node lists like this. And I go, okay, I don't have Ansible, right? I'm not allowed, no Ansible in my environment, right? Like I'm not allowed to do it. I could say, okay, well then I'll cheat a little bit. I'll do my node list, and I'll do that through an awk, like print, oops, print $1, like that, right? I'll just cheat real quick, and I'll throw that into like temp servers or something like that, right? And then could I hit all these servers and get uptime? I'd say for servers in cat temp servers, right? Do echo I am checking $server, SSH to $server, whoops. And then say maybe host name and uptime. And then I want to throw out any bullshit. And then done. Right? And this will go hit all of my, what happened there? Did I spell servers wrong? Oh, servers. For server, yeah, that's my bad. I should have said for server in, yeah. For server and server. Yeah, I normally do server, not server. Anyways, that'll do it. And then now I can go check all my nodes real quick, and I can see, oh yeah, node isn't really there, but whatever, I don't care. But my point is, like, I like those other tools, but I can get around with my other tools, if that makes sense. Like, I have just basic stuff. But the more people limit me, that's fine. It's just going to cost them more because they're always paying my company for using my time. Because you guys know I'm a consultant, and I do this stuff professionally for quite a few different companies. Mostly what people use me for is securing their systems right now. People really want system security, and the government really wants their system secure. But look, I went and just pulled all that information from those notes. And you say, well, why did you show us that? Well, because with Ansible, this is why there's a cult of Ansible. If you make the host files right, I can just say Ansible servers -m shell -a uptime, and it'll just go tell me that all my servers are happy right now. Like, and I'll even see it color coded, which is wonderful, right? Like, are there any servers that aren't reaching right now? Is there anything that's not doing what we want? We would know that pretty. Oh, I should fork that, but whatever. It does. It's only 5 at a time right now, so it takes a little longer, but we can get that back faster. But I can go check all my servers real quick in the environment. All right, guys, I've been missing stuff because I've been over here doing stuff excitedly. I've been missing some chats. Hold on. Let me go look at what you guys are looking at. Another day, another dollar. Yeah. I mean, it's a good problem to have where people want to use your time, but I do try to tell people, like, the more you limit me, especially in like SCIF environments, which is SCIF, which is your secure compartmentalized information facilities, the more they limit me, the more I have to spend time to get around that stuff. I can check Windows servers, Sweaty. I don't have any Windows servers in my environment, but I can check them all. I use what's that tool? Yeah, WinRM. Yeah, WinRM. 5905. What is that? 5985 and 5986 are the ports. 5986 requires certs, though. Yeah. I could talk to that stuff if I need. All right. Anyway, so where are we at? We're doing the lab. So I was messing around. You guys saw me messing around a little bit on the lab. Let's make this a little bigger so we can see it. I'm going to clear the screen. And I'm going to clear the screen. And we're going to go do. We're going to look at. So PS-EF will tell us all the processes that are running on a system, right? These are all the processes that are going. And we can see the UID of who's doing stuff, but maybe I don't want to bother counting those up. So maybe I just do a command like this where it's my PS-EF, so it gives me this output up here. And then I pipe that through an awk to just get this first column. So awk will grab just this first column for me right here on the left. You see my little mouse going up and down right there? And then I'll say sort those so that they're next to each other by alphabetical order, and then unique-c. Unique-c is one of my favorites because instead of just giving me the unique messages, it counts them for me. So I have 113 processes being run by root on this random system that I just came to. So if somebody said, hey, Scott, you looked at all those other things. Is this system doing anything? Well, it doesn't really appear to be doing much. It's chilling at the process layer or with the processes and how much the CPU is being used. But then also, it's not really doing anything except root processes that are running. So I would guess really quickly this server's not really doing anything, right? Just by what I know. But if I want to see what processes are actually touching the kernel at every 1 second slice, I can use PIDstat. So PIDstat will tell me what is actually touching my system. So if I come over here, do I have PIDstat over here? Let's see. Yeah, PIDstat. Let's just go 1.5 here. And PIDstat here for Werewolf is probably going to show us a lot more stuff because this system's doing a lot more over here. So over a 5 second, looking at 1 second slices, it looks like some of these different things were running. Oh, I got that Wazoo modules, right? That's that process. And then it just seems like there's our normal what's going on in our system. How much CPU is being used, and then how many actual CPUs are being. So this is which CPU it's against too, right? So what process? These processes are spread across different CPUs, right? Hey, Paul, how's it going? Paul's local, by the way. I know Paul from my general area. So, all right. So that's all good. All right, so we come down here and I say, why do these have different output? What processors were we using the most CPU, which showed up the most often? And we might need a larger sample to see that here, depending on what's going on, right? And then another one that's kind of nice is this one, this IOStat. This command, if I didn't tell you what this one's doing, what do you think this one's doing, right? Like if I just said maybe IOStat XZ like this, and I just ran that, and then I just left it, and I didn't tell you anything else about this, what do you guys think that's doing if you just kind of watch that for a little bit? Hannah, life's splendid, but got 24 hours, and it hits with 5 hours sleep. Yeah. I actually only got about 5 hours sleep last night before I had to get up and wrestle. I've been wrestling every morning. I've been doing 5 days a week. Kind of wild. That's a lot of wrestling when you're in your 40s. It's like tires you out a lot. This one right here is interesting. This IOStat with the XZ like this will show me. Watch, the first one shows everything. So it shows the CPU. You've only got the one CPU, so there it is. And then all the devices, but all future things are not being touched at all. So now check this out. Yeah, it is I/O for disk. And and then CPU usage. But what it shows, this is what I like about this one, is it only shows things that are in use. So if you were like to ask me, hey, Scott, is VDA being used? Is VDA being held open by a process and constantly being used on my server? I would hit this command, and I would say, no, the last 4 seconds, nobody's used the disk at all. 5, 6, 7, that disk. Now, I know that this is a very short sample, but what I'm saying is I'm watching this system for 15 seconds now almost, and there's nothing writing on the disk. So if you were like to say, hey, is something holding my disk open all the time? And I would say, no, we don't have any evidence of that. Now, is this better than coming over here and actually watching disk I/O on a monitor? Probably not for most of us nowadays. But we're talking about when we're down in systems and trying to figure out what's happening in them, right? This is yeah, it's disk stats, sweaty. Yeah, absolutely. So that's sweaty, not sweaty. Whatever. Whatever. I can't say it. Not enough for the text to speech to take it. So look, you got all these tools, guys. Like, and again, I'm not trying to be prescriptive on any of this. I'm just trying to show you that there's a lot of tools out there. So now we're going to look a little at networking, and I say do each command to think about what output you're looking at. And this one is sar-ndev. And if I said sar-ndev 1.5, and I said, what do you think this is doing? Most of you would probably say, well, that looks like, let's make that small, but it'll fit, right? You might say, well, what is that doing? Well, it looks like it's got all 3 of my system's interfaces. We can go look at the interfaces. But then over here, it looks like we're not really RXing, receiving, or TXing, transmitting, really anything. I mean, God, it's sitting there almost completely idle, right? And you might say, well, Scott, is that a big number or a small number in a system? And I'd say, well, this is why we gather data, because I can't tell you if this is a big, well, I can tell you, okay, 0 is a small number in a system, guys. But other than that, like this system's going to be high. Like if I do sar-n dev 1.5 in my system over here for Werewolf, this guy's receiving and sending a lot more packets because he's constantly talking to all these different nodes in my cluster. And I might just leave that up running over there, right? The sar-n dev 1 will just do it forever. And we can see, is there, you know, what over time becomes kind of our average. And I would say just watching this, you know, our average, well, look, something gave me a lot of receive. But we could also ask ourselves questions like this. Like, we could watch this data over time, and then we can say, does this system receive more than it transmits on average, or does it transmit more than it receives? And then we could start to think, well, is that what we expect? I mean, honestly, like at the end of the day, like what the F and F is this system doing? Is this system so I can't say, like, my closed captioning won't say the F word, but apparently I can get away with F and F. So maybe I'll start using that. So anyways, what is this system doing compared to what we expect it to be doing? I tell you guys all the time, like when you do GUI, right? If you're using like a Windows box like this, the system doing crimes, yeah, that's fair. Yeah, if you start seeing all of a sudden a lot of transmit packets, and then you go look at where those ports are being held open to, and they're all over to like Eastern Bloc, you know, Eastern Bloc Europe or something, like some country where crimes tend to happen, you know, and hopefully nobody's from there and offended, but I mean, it's true. Or so, you know, maybe that's what, or let's just say like Russia or China, they tend to do a little, they tend to be over there a little more loose with what's you know, criminal acts against like U.S. systems. So anyway, so you can get away with more, I think, over there. But anyway, so this system's chilling. It's not doing much, and it looks like it's starting to build maybe a profile of averages. And we can gather all this stuff. This stuff is all exported through a tool called Node Exporter. Do I have, let's see. Let's see. Do I have Node Exporter on here? I don't have Node Exporter on the Werewolf boxes, but the thing, because I do cry. Fair enough. All right. So let's go over here. There's some other things that you can look at, and you can look for errors and transmits. And this would show us if there's any active or passive traffic, and then also if there's retransmits and resets on the line and all kinds of things. You can go look at what all these things mean. But the point is, you can come in here and you can start to figure out what's average for my system, what am I used to seeing, and that kind of stuff, right? And this is the start of becoming, like, we always talk about being an admin and looking at a system and getting it fixed. But another part of that we all want to move over and be engineers, because engineers make a little more, typically. The title of engineer tends to make a little more. And I want you guys to think about your tools in the terms of, like, what an engineer would want to know out of that system, right? That kind of makes sense. Hopefully that makes sense for everybody. All right. Let's see. Is the wife texting me to let me know? Let me see what's going on here. All right. So that's still just lab 1 right there. Look at that, boom. So you did lab. Look at you learning Linux. You looked around at the OS. So if anybody was doing that lab with us, that's on killercoda, completely free. We're going to jump back out of there, and we're going to go to lab 2. So I'm just kind of working through the labs today, at least until the wife gets back from working on. She's been doing Wi-Fi stuff. It's actually funny. She works at the same school district that I did when I first got out of the Army. And I moved up from being a local area network technician to being a local area network technician 2, which it's actually funny. The distinction is not really of any note, except as a level 2, I was in charge of the firewall and all the Wi-Fi for the district. So I used to go out and do wireless site surveys. I drew I had every one of like the top down drawings, I guess you would call them, kind of like a just the map of the campus, and I would go and I would draw out where I thought all my wireless access points should go, and then after I did that, I would go out and do wireless site surveys and test that I actually, putting my things in all those areas. Am I getting the speeds and the stuff that I expect? And I would do that over summer typically, because then the students wouldn't be there. I could also do it during the school year. It's just there was a lot more moving parts at that time. So a lot of that stuff I would do over the summers. It was a pretty good gig. Wife's still over there. 20 some, I think she's got like 20, what did she hit? She just hit 20 something years with them. So, all right, anyways, let's go to this next lab. How's it going, Robodom? We're working and doing labs. And we're not working too hard, but we are working through some labs. Kind of watching how our system behaves. What do we expect to see, and we can kind of learn stuff about what's going on in the system. Also, Robodom's letting you guys know about the Discord over on the Twitch side and on the YouTube side, so that's kind of good. You guys are welcome to hang out in the Discord. In about 2 weeks, no, maybe it's closer to 3 weeks, I don't know, the 22nd, we're going to start a Linux Systems Administration course that some people have done before. It's 16 weeks long, it's free. You just kind of have to, well, okay, free in that you have to do a whole bunch of work. Atticus, how's it going on the YouTube side? But then also we're going to start that same time, well, a little later in the day, but that same day, we're going to start our Linux Systems Engineering course on securing systems. So security of the Linux systems, right? Like how do we lock down Linux and make Linux safe as an OS to different standards and what our considerations are and all that kind of stuff. So I think that that'll be a good course for people that haven't done that stuff and haven't done it professionally for sure. Because obviously there's just doing it and keeping your stuff secure, and then there's doing it in such a way that it keeps the company and regulators and your GRC team and your, all those people happy. There's different levels of this. Yeah, Robodom, we're doing the security course. We'll start at the same time as the sysadmin course, yeah. And it's funny, we're going to start it on the 22nd, and then I'm going to be out of town on the 29th. So the 29th, we will not have a meeting, unless people want to just have a meeting and hang out. But the second meeting will officially be that in April or whatever, and then we'll continue on from there. So yeah, Atticus, you're welcome to go. There's a really cool, the guys have been putting together a really cool book on it, so I can link the book if people want it, but they put together a really cool book. This is all the course, and it's free, right? This is just a free book. It's got, for Unit 1, it's got what you're learning. They've been adding more and more stuff to it, but at the end of the day, it's still the basic worksheet. They embedded the YouTube for the videos for each week. Yep. And then they just have all this stuff. So I can link this if anybody wants it. You guys want this stuff? This has also been linking, I think, in Twitch. So I'll just drop it on the YouTube side for people that want it. There you go. Oh, maybe Robodom had just given it to you guys, so that's good too. Yeah, but it's at the end of the day, it's just more things to go practice. And then what I'm trying to do in this course, main thing to understand about this is you're doing Linux. We're all doing Linux, right? All of us here are trying to get better at Linux and try to understand it. But this course is more what is Linux doing and how does the business want to use it, right? If that kind of makes sense. So this is like, how are you going to interact with, you have to do these tasks, but how do they work in the concept of like working with the business, right? That kind of stuff. Yeah, the first couple weeks, technically you could probably get away with missing the actual, plus again there's a recording. So they put the guys put the recordings in each of the weeks. I don't know, they get together every Saturday and talk about it too. So if you guys were like, hey, I want to go contribute to that book and have my name in there because that would look good on a resume, I would tell you to go get with those guys and start working on it, right? There's a lot of good stuff that you guys can get involved with, which would show, when somebody says, hey, because at the end of the day, right, when you go to get a job as an administrator in Linux, there's going to be people that have applied that all know how to do some Linux. And your major selling point is going to be, your two major things they want to know is, can you do the job? Will you do the job? Well, can you do the job? I can tell that in like 2 minutes talking to most engineers. But will you do the job? Well, I mean, I think if you're very active in a community and working on stuff, people are going to be like, yeah, this guy likes Linux. He'll do it. Are there any good business books for types of models they use? Zenochez, I would tell you to go to this site if you were like, hey, like, um, this is the question was around any good books for models and stuff. I would go to the sre.google books right here. There's a free books out there. I'll just drop this on the Twitch side because I put this on YouTube a little while ago. But this is a good set of books right here, I think, for people that want to see like site reliability and uptime, which is a small portion of what we do in the Linux world. However, I will say this one thing. If you're on an operational team, the number one key performance indicator, or what we call KPIs, the number one key performance indicator of any operational team is uptime. How much do we keep these systems up and available and useful for our different systems? Atticus, now this is practical education with real world application, not abstract info. Yeah, like this stuff here where I just tell you guys to go to the labs, this is push buttons, make Linux respond. This is valuable. This is like rubber meets the road stuff for sure. You need to know this. But the course stuff is less of this. You know, it's less of just putting in these things and getting answers out. It's more of like, what is the business going to use this stuff for, if that kind of makes sense. So, yeah. Like in this case, like you might know uname-a gives you this information, and you might know like, you might know that there are these kernels on the system, but you might not know that if you did like an ls-l boot VM asterisk like this, that there's actually only one real kernel here. The other ones are just links to the same kernel. So you might think you have an old version of the kernel on the system that you can boot to, but you can't, right? And you didn't know that just from these commands. You had to kind of look at this and go, wait a minute, I only have one kernel there. And then you say, okay, well, that's the kernel I'm actually on right here. But then you say, well, how was that kernel called? And you know the proc cmd line, or you know dmessage, and then like head to see the first 10 lines, and then you can see here's the command line. So the kernel command line from proc command line, or the kernel command line right here, as it was called and handed off to by grub. Yeah. So there's like, again, this is discrete tasks in Linux. Can you check this thing? But then the Linux sysadmin course is more like you're looking at this in the holistic context of how a business wants to use it. I guess that's the way I would differentiate them. These are discrete tasks. Can you go tie your shoe? You know, but do you know when to tie your shoes and what your schedule is for the day? That's different. Also, Orcs, thanks for the follow. That's a pretty funny name and pretty good name. I have to say Orcs because that's the only vowel sound. All right. Here's a fun one. That's the whole lab. By the way, guys, that's the whole lab for this one, is just click these things, look at these, see what's kind of going on with the system. Here's a fun one. Can anybody, I don't care if you use Google, I don't even know if Google will tell you this. Google might tell you. I think AI might tell you this too, but can anybody tell me in that 0RCS orcs, where I said I needed it because there's only one vowel sound, does anybody know the difference between a vowel and a consonant sound? I've asked this before. Some of you guys might know these. But does anybody know the difference between a vowel and a consonant sound? All right, next one. We're going to look at checking the disk and mount points of a system. Boom. So there's the killercoda lab. If you guys want to do this with me, it's free. Vowels are more important. That's funny. And Enzo Bear, maybe in some ways that's true. You just figure out how to exit Vim. I like it. Enzo Bear, you said you skipped schools. That's fine. Well, Enzo Bear, I'm going to teach you something then. And by the way, you do need to know this if you ever choose to like teach somebody how to read, like especially like an adult learner. You do need to know the difference between vowel and consonant sounds. All right. Not to put you on the spot, but Enzo Bear, you do know all your vowels in your language, right? Because Enzo speaks a couple languages, I know. Yeah, A, E, I, O, U. I want you guys to think about when you make those sounds with A, E, I, O, and U. In a vowel sound, no part of your mouth needs to touch any other part of your mouth. The sound is generated from your throat. All consonant sounds require parts of your mouth to touch. Your teeth to touch, your lips to touch your teeth, your tongue to touch the top of your mouth. So as you think now through, as you say things, that is a consonant sound when some part of your mouth touches another part, and vowel sounds are all generated from just your throat. So there you go. You guys learned something. If you learned nothing else useful from me today, well, that's not useful, but that might win you like a trivia one day or something. All right, look at this one. This one says, you are a new sysadmin at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation. Now, I've told you guys this before. This is true. You will not see a lot of documentation on systems sometimes. You know, sometimes you will not get a lot of documentation about, like, what's going on in the system. Let me move this over just a little bit so you guys can see. Actually, I need to do it here, I think. Move that over. You guys can see that a little better. Okay, there we go. All right. Yeah, or it's also very fair to say most documentation is outdated. Or, Robedom, another way to put it is nobody's looked at that documentation in a long time. And one of the things I would challenge you guys, if you want to be like looked, if you want people to think, hey, this is a good administrator, this is a good network operations, you know, that he works in the NOC, but he wants to move up, keep your documentation squared away. It is easy to, by the way, you might think it's hard to. No, just make yourself a little calendar alert every month that pops up on the last day of the month, right? You can have it be like the last Thursday of the month if you want, or last Friday. And just take that day to go and touch every one of your pieces of documentation. And when people go and look at like your Confluence page or your whatever, your documentation page, Media Wiki, they'll be like, man, his stuff is always up to date. Hey, his stuff is always good. And it's like, it doesn't even take that much effort to be good at this stuff. You don't have to remember to go do it. Your system will remember for you. You just have to go do it, right? So documentation is, yeah, it's huge, Robedom. And honestly, I think the better you document things, the better people are going to think that you're an engineer. Even if you just feel like, oh, I'm faking it till I make it, you're not actually faking it anymore. You're being an engineer by engineering stuff, right? And you're putting your thoughts and your energies into actually building stuff. So, yeah. Yeah, it can be. Read the man pages, make little notes and scripts. I'm a big fan of understanding the things. I know we can reference them. We don't have to memorize everything, but having notes for the way that you would run something is pretty valuable. It all costs money. He said, speaking of documentation, I spent the last week working with OpenAI and DeepSeek to create a step-by-step guide for setting up and configuring my home lab and network. It's about 20 plus pages so far. Wow, that's pretty good. So it all costs money. There's two types of major documentation like that I build as an engineer. What it sounds like you're doing is the build doc. The build doc is the way this system is built from nothing, right? That's a build doc. And build docs tend to have a bunch of different component pieces of them that can be added or removed or whatever. And then the other piece you want to build after is, yeah, that's a pretty good idea. It all costs money. That'd be cool. And then the other type of doc you want to build in an environment is what we call the run doc. The run docs are the doc that you pull out, and a lot of times it's componentized down to all the different things we do. Like, this is how you restart a werewolf node. This is how you update a werewolf container that won't start. This is how you, it's just a bunch of stuff that is your typical running day in the life DITL, right? Day in the life testing and running of a system. Yeah. Yeah, it all costs money. You should absolutely drop that in the Discord. If you want me to make a Saturday, or me or Treasure, either one of us can give you, we can make, if you were like, hey, I want to have like an event, and just plan it out a little ways so people have time to look at the events. I'll call it out and tell people to go to it. But yeah, I think people will probably show up if you say, hey, I want to show you guys how I built something. I think people would be there for that. So, yeah, Hayes, I can see that having a lot of issues. However, you do have JQ, which will let you know that it's at least formatted right, which is nice. All right, so we're going to check some disk information on this box. And our validation failed because we haven't done anything yet. So I can do fdisk. And fdisk is one of these just old commands that still works well. With a -L, it will dump way too much crap to your screen. But if we capture that output that was coming to standard out, and we throw it into standard input for this grep, which will filter down by ignoring case VD, it will find any of these virtual disks that are used within the system. So there's a VDA disk, which is 20 gigs, and then there's 3 partitions, 1, 14, and 15 on this system, right? So another way I can look at that is ls block, and here's my 1 disk and the 3 partitions for that disk. So that's pretty easy to see. I can do a block ID, and I can see information about the file systems on there. That's really important. Are we using ext3, ext4? Is it XFS? Any of these types of things? Now, if I built the server, I know those things. So on the engineering side, I know exactly what all of my systems should be. But again, the scenario we're in is we're in a new environment, and we don't know. So until you actually see, and let's say you find documentation, but like Robodom was saying, it's out of date. So this is one of these things, we call it trust but verify. Like, hey, I might trust you that the system is exactly like you said and it's all ext4, but now I know it's ext4, as opposed to like XFS is the different type of file systems that we might, I said ext4, oh, whatever, it doesn't matter. All right. So then there's that, and then we can just add those values, and then we can move forward on the lab. So now we can check file system and mount points. So we clear this up, and we go in here and we look at, if we wanted to just see any of the VDA disks that are mounted, we run the mount command. The mount command is going to check against the etc m tab on our system, /etc/mtab. There we go. Wait, is it going to change it? Whatever, it's not going to do it. So it reads that, and it gives it to us in this format that shows us the disk and then the mount point. So here's the mount point of root. That is the root of our file system, is on dev VDA disk on the first partition. The boot EFI is on dev VDA 15, right? And then there's some information about the file system type, and then also any default values that are set as options on there, right? So I can see that real quick, and I go, okay. So let's check the file system that's written to the partition, and then let's use another command to see this. Let's do block ID for just dev VDA, and I see that it's ext4. I also see that that's how it's mounted, so it's good that that lines up. By the way, normally if you try to mount something with the wrong file system, it's going to break anyways. So there's that. It's mounted. Here's its UUID. Here's its part ID. And here's its label. Well, how did it know to use that as the primary disk? How did it know to use dev VDA1 from that label? Well, this is back to what we were talking about earlier, cat etcfs tab. And I see cloud img rootfs is supposed to be mounted as /. That's what's read as the system first comes up and wants to switch off of its init RAM fs and kernel to it does a switch root over to this label. And we found that label by cding into dev disk by, I don't know what the hell I'm typing. And this is by label. And in here, we see that cloud img is also going up a directory, dev disk VDA1. Or dev VDA1 is what that is, yeah. Yeah, there's VDA1 right there, so that's the mounting to it. Yeah, I can't believe I just typed a different value than disk in the damn command line. Oh God! On Twitch, people can they can capture that forever. Well, I can go delete them, but they can capture stuff like that. It's kind of funny. All right. But hopefully nobody does that. All right, so I don't actually care, but we can throw that information into a file. So instead of coming to the screen like this did earlier, right? So we did that command earlier and it dumped everything to the screen. We captured the output that was coming to standard out, which is the screen, and we threw it into a file. We said, nope, catch that, filter it down. It kind of looks like we're filtering it. It's a greater than sign, and it throws it into a file, root fs type. So if I were to cat root fs type, without knowing anything about that, it should look exactly like this command, like this output right here, right? I'm just gonna hit enter, and this is this. See that? So, and some of you might go, oh, Scott, that's really simple. You're showing like redirects and pipes. Well, you know, some people have never seen this before. So like sometimes we gotta spend a little time with it, right? We gotta show all this stuff that's kind of hanging out there. So, all right. So anyway, so then we go and we cat /fs tab to see that same stuff we were talking about. This is one of these things I tell you guys, like this is the discrete task, cat /fs tab, but that just shows you some stuff. What you really wanted to know out of here was this label information around what we found way earlier in mount. Now we could go type mount like that, or we can just bang mount. Bang is your exclamation mark, and it will run the last mount command. And I would see that the root of this file system is off of dev VDA1, and then I would map to, in here, the root of the file system is off of cloud img rootfs, which is a label. That label is here, which points back to VDA1. Everything's happy in the sister. In a row bang, yeah. Yeah, so that's, again, discrete task is, hey, can you dump out the files, the place where our system finds how to mount disks and partitions and NFS shares and that kind of stuff. Yeah, I know how to do that discrete task. But why? How does this work in the system? And that's all of this other stuff. Does that kind of make sense? Like, I tell you guys, all this stuff is just magic until somebody shows you, and then you go, it's not magic. That's simple. That's all. That's literally like we're sitting around playing that game Chutes and Ladders, and when somebody goes and falls on one of the chutes, they go slide down over to here, and if they try to slide anywhere else, we go, that doesn't follow the rules. What are you doing? Get over there and fall where you're supposed to. And it's like, yeah, and Sweaty, that's actually something that people have asked me before. What's the standard here? And I'll tell you, I've seen, man, Ubuntu tends to use labels. I've seen Red Hat recently using UUIDs a lot. I tend to, because I sometimes build high-performance compute type stuff where head nodes will share disks between them off of iSCSI. And because the iSCSI paths are always the same, I have done iSCSI in here before. Because everything else I can't trust. So it's... Oh, and that's by path. So if we cd to dev cd disk by path, right? And this would be your PCI or your virt.io in this case, or SCSI or whatever. And I need it to be exactly that, because I know that path isn't changing unless somebody goes and pulls the cable, and then that's when I would do that kind of stuff. So, yeah. But Sweaty, using labels is perfectly acceptable. I tell people, this is one of these things where it's like, you could ask me what the best practice is, and I would tell you again, Ubuntu's doing it one way, Red Hat's doing it another way. The best practice is do something that does not change, and do what's right in your environment, because you're going to work with other engineers. You're probably not the only Linux engineer in a company that's got any more than maybe like 200 Linux servers. If you like a challenge and you like to build all your stuff differently and you're the only one doing it, fine. But if you want other people to be able to support your stuff, you have to do it all the same. And you say, well, nobody should ever touch my stuff. Yeah, but here's the thing. In the industry, if you want to take a vacation, you need to document your stuff. And I tell you guys all the time, one of the things that made me better at documentation and better at updating all my stuff was because I didn't want to get called on vacation. And you will, as you get better and do this more, you will be the only one that knows how something was built. And if you don't document it, you will be called. That's all there is to it. Unless you quit the company. But I wouldn't quit just to go on vacation, right? I would just get in the habit of building stuff right. So anyways, the point of that is I'm not going to tell you guys like how to make your tea or how to make your coffee or whatever. It's just make sure that you do it a way that's understood and documented and other people can support it in your environment. That's a big part of what we do is like, it's repeatability. Like an engineer that has to do the same thing multiple times is wasting his time and his company's time. Well, his time and his company's money, right? The value that I provide a lot of times is I can do a lot of stuff and automate it. And then companies are like, oh, that's really cool. And then my company just, sends me out to a lot of different projects and stuff to just do these simple things that really complex for them. It looks like I'm casting spells until I show it to them, and then they're like, "Oh, that's not that hard," and I'm like, "Yeah, well, but that's what you paid to learn, basically." So, anyways, all right. Anyways, so you can go look at all this stuff here. Yeah, and guys, I tell you all the time, I don't do anything that, like, especially people that have been here for a while and do Linux. You guys are going to be like, Scott, you don't really do anything that super complex, and I tell you, I know I don't. I know I don't. I just do simple things well. I've always done simple things well. That's made me a decent to good engineer, right? And kept me in the industry. All right, so anyways, we echoed that file name into root mount info because that was the place that tells our system where to mount everything. And then this last one says, can we check some disk size and usage, right? Yeah, Hayes, you just got to get back into it. You just keep playing with it. So check disk size and usage, find the size of the partition for root, put in a file called root size. Place a single file in that's 3 gigs called root big file, and then place 10,000 files in the root directory as well. So our answers are down here. So I can do a df-h and see here's root right here. And I can limit that down, by the way. Maybe that's annoying to me, and I say df-h on just the root file system. That's all I want to see. Yeah, Hayes, I will agree that, like, you have to keep doing this stuff. This is one of the reasons I come on here and stream, is I can just play around with stuff and show some of the basics to people and stuff, and show people that you can go do this professionally. Hayes, I actually show tree in some of our Ansible stuff. I don't use it myself, but I think it's a really good place to start for, like, newer admins that have a hard time kind of visualizing, you know, where they're at in the system. You know, like PWD and LS, and they're like, okay, I'm down in here, and then what's, you know, I don't think tree's on the system by default, but yeah, then you could use tree to find stuff. So I don't use it much, but I think a lot of newer admins and engineers might find that useful. Fedora is nerve-wracking in that regard. Whatever they do is their default. Yeah, ButterFS is not anything I've ever run professionally. That's BTRFS for other people. But I've never run that. On random reboots, the labels are gone. Then it falls back to UUID, rewrites the FS tab, and forgets to update the labels, which confuses it, triggering some other restoration. Yeah. Pack, I will tell you, I've never seen. I don't think I've run Fedora on a desktop since I was running Fedora in 2019 on a server at work. Well, a desktop at work. That's the last time I've professionally run Linux on a desktop. I don't. Some of you guys know I don't run Linux on the desktop, mainly because I get other functionality from my other tools, and I'm okay with it. The company wants me to run whatever, I'm fine with it for security reasons or whatever. I don't care, right? They can have their endpoint protection and that kind of stuff, and that's good. Canby, you said you have a joke about documentation, but it's not fun. That's actually pretty good. You guys know I got a pretty good dad joke. I like it's what do you call a beehive with no exits? Unbelievable. Oh, I love that one. I found a handy bash script that implements tree, handy for Mac. Nice, Hayes. Yeah, that's pretty good. And I tell you guys all the time, like, don't ever take anything I say on here as, like, prescriptive. I'm not trying to, like, force you guys to do things a certain way. I'm not trying to, like, tell you guys, oh, like, don't use ZFS or do use ZFS. Like, I try to show you guys the way that I do things, and all of my stuff will always come back to being very, like, simple. You guys will see me, like, often follow what I think is the path of least resistance, right? People have tried to, over time, show me, like, something other than wait, is that highlighting down there? Yeah. They've tried to show me Tmux because they're like, Tmux is so much better than Screen. Screen's been discontinued, and I'm like, well, I guess I'm getting decommissioned when Screen does. No, I'm just kidding. I can use Tmux a little bit, but for the most part, I have this one tool, and I'm like an old dog that doesn't learn new tricks. So I just keep doing stuff the same way. Anyways, all right, let's keep going here. So we did our df-h, and we got all this information. So now we're going to say df-h, and just building that command down there, we're going to remove size. So it's going to get the top part out. And then we're going to awk, and we're going to print just the field that we want, which is the second field right here. print $2, and that's going to give us just the 20 gig. And then we're going to drop that into root. And what do we call this thing? Size. Just the name of a file, root size. And it's 20 gigs. And we just did that so that the lab would let us go forward later. Yeah, Hayes, there's a lab. We have a lab on Tmux. In fact, it's the only lab that somebody else started in all of our Prolog labs. I tell you guys, you can make labs if you want. You just got to let me know, and then we can do a pull request and stuff. But yeah, that's there. Okay, hold on. Ooh, the wife said Jersey mics. Yes, but just medium. When did she send that? Okay, just sent it. Okay. Okay. All right. So, thanks for reminding me. Okay, good. So we do that. And I said this command cuts off the unnecessary information. You can check its output by just removing that. So yeah, that's true too. Just take that off and just dump it to the screen so you can see it, right? That's always useful. No, actually, Albert OG over on the YouTube side, the wife is getting Jersey mics, which is not bad. I like Jersey mics. We've only had that out here in Arizona, I think, for I don't know, maybe 8 years or so. It's not like something that's been here since I was a kid. Paul, yeah, so on Saturdays, we're going to start running the... so Paul asked, are we going to start doing the class on Saturdays? Yeah, the Linux Systems Admin course is going to start on Saturday the 22nd. And then there's going to be a security engineering course that starts a few hours after that, also on that same Saturday. So I do like Firehouse subs as well. Yeah. Zeno Ches. That's funny. I like that name. I like that. So, yeah, so let's keep looking at here. Let's make a big file. So if you've never, this is a fun one, df-h on root, we cd to root, and let's just make a big file. And we can do the command down there, or we can write it out. Disk duplicator will take an input file of dev0, meaning it's just going to go to the processor and ask for a 0, and it's going to get a 0 each time. So it's just going to make a bunch of zeros, pull them out of thin air. And then we're going to say root big file, and then we'll say bs equals 1024k. That's our block size, so 1 meg. And then we're going to say count is equal to 3,000. So that'll be 3,000 megs. And then I want to come over here, and I'll show you guys this real quick, because you might say, Scott, why did you point out right here that this was dev0? What are the other things that I could have done there? Well, let me show you real quick. Let's just write a bunch of zeros to the system. And we'll do the lab real quick. A bunch of zeros took the system it took the system about 2.5 seconds to write. That's what it says here. And it says right here that, yeah, it took 2.65 seconds, which is about what that saw. This had a little bit of stuff around it, but that's about accurate. Okay. So real quick, let's do a df-h on root, and we'll see that now we have 3 gigs less available than we did. We've got 3 gigs more used than we did. So we've filled up the file system. But I want to show you what else we could have done instead of dev0 right there. Instead of dev0, we could have said dev-random, meaning I need the processor now to spend time thinking of a number between 0 and 1. Well, 0 and 1 are their only 2 options, right? And now this is going to take slightly longer to write because it's actually using, and you're going to see here that it's using more system time. So to generate 3 gigs of this is going to generate 9.6 seconds worth of time, and almost all of it's system time. Up here, very little system time used. Well, in relation, it's about the same, but down here, it took a lot more to give me random. Now, you also have another one you can use, which is urandom, and urandom is not going to be related to system noise, so urandom should work at about the same speed as random if no disk I/O is occurring. And actually, Robbie, when he comes and talks to the group, sometimes he tells you some interesting stuff here. So it took about the same, 9.5, to generate just random numbers and write them into that 3 gig file, right? But what I wanted to show you guys is this. When you use dev0, this is why this is very important, guys. Dev0 is what you always want to do when you're testing your disks, your disk like I/O out to, let's say you're going and looking at like a SAN storage and you're updating your SAN storage. Well, I just want you to think about this logically for a second. You want to use the one that is not dependent on the processor in any way. You're using this idea of what we call ceteris paribus, where I hold all other things, it's ceteris paribus. God damn, it's not, it's ceteris paribus. There you go, that's right. There you go, that's it. But what I wanted to show you guys is you use this because, look, if this is going to take longer, well, this will take longer on different nodes, too. This will take longer on a node that's under different load. So this is not fair, if you want to think of it as fairness, to the file system that you're testing. There you go. There's Sweaty. There may be a dev1. I've never used that. I've always just used dev0. So I just use dev0. I don't know if there's a dev1. I've never tried that. I've always just used dev0 and grabbed zeros off the block. That's actually funny. No. There's not. There's an ls-l dev0 though. So that's actually a question I have never thought to ask Sweaty. That's really funny. There's no dev1. It's just dev0, dev-random, and dev-urandom. Those are the only ones I've ever used. Those are the only ones I've ever shown anybody. That's actually really funny. Could you make that? Yes. Yes, you could. Yeah, you could make... So, I've got a lab where I show you guys how to make these, but I'll go pull it off my GitHub. Because I don't remember where it is except here. In our stream setup. Oh, hold on. Roles, bastions, tasks, main. When I make that file, so dev0. So I should be able to just make, we're going to change this a little bit. If I was going to make this, I would do zip dev1, and then we don't need the var ch root. Let's just see. Yeah, there it is. I don't think that it would still be dev1. I don't know what it'll be though. Yeah, there you go. All right. Also, there's a dev full, which emulates to drive this full. Interesting. I did not know. I did not know there was a dev full. Yeah, there it is. Look at that. Yeah, you learn something new every day. I didn't know there was a dev full. Look, guys. As far as a lot of this stuff goes, I only use the things I use, right? And I've run into a lot over the years, but I've never run into dev full before. Yeah, look at that. There's probably some other things in here we could mess with. Anyway, so guys, that's you know, this is what we do. We go play with our systems, right? And then we just sit around and think about how happy we are that people pay us for it, right? So good. So we can go look at that and see that that file is there and it is exactly the size that we expected. And then we're going to go ahead and, oh, we already did that one. So now this other concept comes up a little bit. So I'll do a df-i on the root of the file system. And you'll see that I have, this should be 2.4 million free inodes. Inodes are positional places where, or addressing, where we can address and put things in the size of the file system. So the size, this is like the bookshelves where all the books are stored and how much information can be out there. And this is like the pointer to those, like the card catalog, if any of you guys remember that from the older days of libraries. So I'm going to touch 1,000 more, and then we're going to look and we're going to see, 10,000 more. And you're going to see that I've used 10,000 of those up. I've used 10,000 of them up from our 2.4 million or whatever. And we could keep upping that number, and we would slow our system down, but we could generate more and more. Also, you're going to find that globbing like this. This is a wildcard right here. This is going to have a limitation. You are going to find a hard limitation pretty soon. I think you find it here. Yep. So if you were trying to build 100,000, you might think, how am I going to build 100,000 files? I can't use this normal bash concept, right? How am I going to generate those? And you might say, well, what if I did this a different way? Could I maybe say this, where maybe I go for I in, and then I count sequence 1 to 100,000 maybe, and then I say touch root file $i, right? So that'll put the number there, and then done. And maybe I want to time all that to see how long it takes in my system. You want to do. Oh, my bad. You always got to do and then done, right? So now this is going to sit here and spin as it goes and builds all 100,000 of those. And we should be able to come right here when we're done and see that there are 100,000 less. We should see 2.355286. So 2.3 or 2.3555286. Now these numbers could change. Other things could be happening in our root system. I don't know. But I can tell you for sure that we're going to have 1 million or 100,000 less rather when this is done. Also, I think this takes over a minute or two to do because it's doing 100,000 in a non-efficient loop. So we might want to look at how that loop happened, right? And then we can do other stuff. Runamucker share. Hey, how's it going? Sequence Respector. Yeah, Sequence is a great tool. Like, because I can count to 100,000, but I don't think any of you guys would hang out here and listen to me do it. Actually, it's kind of funny. Like, when you do stream, you'll find that there would be 1 or 2 people that would hang out with me to count all the way to 100,000. That is actually one of the cool things about streaming is you will find somebody that'll sit there and listen to you talk about anything. But since I don't want to bore everybody, we're doing this for a purpose to see our inodes be used up and to keep everything kind of going. So yeah, we're getting stuff going. Also, Robdom, aren't you at the conference right now? Aren't you at the Scale conference at this very moment? That's pretty cool if you are. Last I checked, I think you were, or I think you mentioned that you were. Yeah, it can be. We could have backgrounded it all. Yeah. So actually so let's compare this. So Canby said, what if we did this? What if after our $i, what if we said do them all at the same time? So we're going to change it from root file to root like test. Oh, by the way, one other thing before we do that. I'm just going to put a pound sign in front of this so it's still there. And I'm going to say df-i on root to see that, yeah, we used 100,000 more. Now let's go do this command, and let's run this command with the test and kick them all off at once and see if it takes less time. So basically, it's just going to background each one, not wait for the next one. It's going to kick them all off at once. In fact, coming to the screen has probably slowed that down. Wait, like, yeah, it's the writing the standard out that's slowing this down. 100% for sure, 100%. Yeah, this would have went faster, but by the way, we could go run, we could compile something in C that writes that, and we could see how much faster C is than anything we do in Bash. But then I've got to compile this very specific tool for this very specific one thing, and that's when you start realizing, scripts work pretty well for most of the stuff that we kind of want to do, right? And then we do write functions if we need to, and we can write stuff down and see if we need to. But a lot of times the tools will do most of what we need. We're only about halfway through. Yeah, I think we actually slowed it down by writing the standard out. All right. on. All right. One of my buddies just messaged me and said that he wrote a novel way to in a Python script for automating difference and differences, and he's writing a paper about it. He's an economics professor. Actually, he left economics teaching, and now he's doing it for a company. But anyways, he said he's going to write a paper, and I said, hey, well, come tell our group about it, because he's come and talked twice now to our Linux group. So he just texted me and told me that he was doing that stuff. And he said it's going to save a whole bunch of time and money for the company, but nobody's going to be excited except for him and the CEO. So I said, well, or come and talk to all our guys, because all of our guys will think that's cool. So all of our guys will think that's real fun. So we have a fair amount of people that code and or, you know, front end, back end, software type people in our company. So, or in our group. So, you know, we are Linux and we do focus on the platform, but we touch everything that touches the platform, which is all of that stuff: site reliability, DevOps, automation, all those things, right? So this is what we do around here, guys. This is dramatically slowed down. It's gonna take like 5 minutes. it's barely 2/3 of the way done right now. Just past 2/3. It's really funny. This is dramatically slower because we threw it to the command line or to the standard out. If we suppress standard out, actually, you know what? It might take longer to show that than it actually took to do it. That's funny. Whatever. That may have been done. We'll have to wait. I think our time just flew by too, so that's actually funny. Oh well, right? Like this isn't stuff that's that big of a deal, but this is fun to see though. We're at about 3/4 right now, so. All right. We might run out of time. No, we won't run out of time on this before the end of that. But do you guys see how like these labs, even though they're the very basic labs that we originally start with in our killer coda, there's so much other things you can do than just push the button over here on the left. The button over here on the left will do the lab for you, and it'll show you things that I think are of value if you've never been in this space. But then you can come over here on the right and just mess around, right, and muck around. Yeah, it can be. Make mistakes, figure stuff out, reevaluate, shoot a new azimuth, keep going, right? This is what we do. So this is what you get. Yeah, paid by the hour. I am salaried, but so it's actually kind of cool. I work 100% with my company on one project now. I'm going back over to NOAA, which is the National Oceanographic Atmospheric Agency. I do work for them on their supercomputers, but I also am kind of embedded on a bunch of these other projects. I've joked around and told you guys it's almost like I get dropped in, like airlifted down and dropped into the middle of whatever, and I just do work on these systems. And that is paid hourly by my company. So when they charge companies, they pay me. So that's kind of cool. Like I'm basically a 48-hour salaried person with options for, I wouldn't say unlimited overtime. It's almost forced overtime. But at least I get paid extra, because really as a salaried employee, they could just make me do more, right? You know. But my boss incentivizes it, which is kind of nice because, you know, he runs the company. So I think we got about 40, 45 engineers or so. We're not huge, but we've been around. That's just 45, not 4,045. It's almost done. When this number on the left hits 100,000, we're done. That's really funny. That took longer than it should have. Yeah. Oh, but it's only straight hourly, but it's pretty good hourly, so it's not. I don't get paid overtime like 1.5 like some people would, but my hourly's okay, so that's fine. If I were paid hourly, my hourly's okay. So, all right. It's almost done. We could think of Twitch as paying me hourly. Oh, that's not true. Oh, it's almost done. It's going to finish right here. Right about there. Right there. Oh, it tells me done. Okay. And then I had hit enter earlier, so it actually missed the time that it took. And I don't think that's stored anywhere, so I don't know how I would see that. But I would call that a few minutes there. Um, probably almost 10 to do that. So that was definitely not faster, but just because it was coming to standard out. So, all right. Anyway, so we did all that. We looked at these things. We kind of, as we say, grokked or understood what was going on. One of the cool things is we could do a history at any time and see all of our commands, like all the things we did, all the things we played with, and kind of what's going on within the system, right? Some of you guys might notice too that little thing that keeps popping up on Nightbot. It comes every like 20 minutes or something, but I did extend the book coupon into March, so people that do still want the book can get that. But that's such a small part of all of this. I think there's so many things to go spend time with before you ever go buy the book. I tell you guys, do all the labs first before you ever go, pay anything for the book. Anyway, so if we went in, we could get to the next lab. The next lab is IP and open port information. It's networking. And then we start getting into some of the system stuff. But all these labs are here for you guys to go do. Some of you guys have played around with this, and I've shown you guys, like, there's no cost to killercoda. They have never charged me anything. I've spun up thousands and thousands of labs with them, and they've never charged me anything. So I think they're a great little tool for, oh, you want to go learn a little bit about attempted. Oh, somebody was asking earlier about Grafana. So here's Grafana stuff right here. And then I've got some presentations inside of Discord and on YouTube that show how to build your Grafana, right? And what you might do with Grafana from like a systems operations perspective, that kind of stuff. And this kind of gives you a nice starting point to then go build stuff from. If you don't want to, you don't have the resources for having multiple machines in a lab and stand this all up, just go build it out here, play with it, see what's going on. And then we had one of our guys in Discord, was it Kolkus that did it? I forget who did it. But he did, one of the guys did a really good thing, and then they dropped it up there. And it was deploying Grafana via all Ansible in their lab. So once they got their lab stood up, they could just push one button with a playbook, and it would deploy the what did I say earlier? Yeah, so it was Node Exporter, Prometheus, and Grafana. They deployed it all. They put all the dashboards up, so all the dashboards were automatically pulling information, and all you had to do was go log into Grafana. And I thought that was a pretty cool little project. That was one of our guys did that. I may even ask those guys to let me use those for describing the projects for the next one. Like say, hey, do you want to be used as an example of the project so that people can go and look at, what's going on, that kind of stuff. Look at this system over here. This system isn't doing nothing on the disks. Nothing going on down there. It's very, very low processing against the system. All right. So anyways, I do have to get off of here soon, but I wanted to kind of just show you guys around some of these labs. Like, we're always working on different labs. We're always talking about different stuff. But I want you guys to know that there's a lot of this stuff that you can get in here and play with and understand better. And then, also challenge yourself by going and maybe building a lab. Finding the time to build that and show other people how to do something. I think that's valuable too. So, all right, I'm gonna drop us in a raid. Let me go find somebody to raid over on the Twitch side of things. Let's see who's on right now. Who am I following that's on right now? Rox, Codes, Oliver, Kai is on. We go over to Kai. Kai's always doing fun stuff. They're building servers over on Robitech. Yeah, it can be. I appreciate you guys coming by for sure. Let's go raid over to. We'll go right over to a software and development guy who's doing some fun stuff. I like watching Oliver when he builds stuff because he builds and designs really cool things. So we'll go right over there. And the raid message is our normal do all the Linux. So I will talk to some of you guys later. And I'll be just down in the Discord hanging out later on tonight. All right, take care, everybody.